So here's the stock price. It's a company called Beyond Meat, lists on the Nasdaq, and here's their daily stock prices. So the closing price. So July 22nd, it was $6. If I go all the way down, so these are every day the closing price. Um, Yesterday, the 21st, it closed at $4. So it was $6. It's $4 now. It's dropping. So here's a price. Here's a graph of the price, and it looks like it's dropping. We want to calculate the drift, which is a measure of how much it's dropping or how much it's growing, and we want to calculate the volatility. So the the drift is a measure of how fast it's going up, annual, and the volatility is a measure of how jumpy it is. So let's take a look at the formulas then to see what we're doing. So the drift, when we talk about the drift, we want to talk about the returns of the stock. So those are the actual stock prices. I need to calculate the returns. The return of the stock is going to be what I can sell it for minus what I bought it for over that day divided by what I bought it for. So let's go back to our spreadsheet here and calculate those returns. Okay. Well, the first day I could sell it for 616 and I would have bought it for 616, so I would have made it no money, and I'm dividing it by the 616 to make it relative, so the return was 0. So these are the returns here. These are daily returns because I'm using daily data. Let's drag that and calculate all of these returns. Okay, so sometimes they're positive, sometimes they're negative. Like just for instance, looking for a positive one, that was if I would have bought it September 4th and then sold it September 5th, I would have made 4.3% on that investment because I would have bought it for $5.95 and sold it for $6.21. So that would have been a good day. But most of the days are negative. So to get the drift, first I need the expected return. So the expected return I mean the average return. So I'm just going to take the average of all of these returns. Average return is negative. Yeah, no surprise it was dropping down. That's the average daily return. If I want to express it as the drift, then I want to multiply it by the number of, not the number of data points I have, but the number of data points there would be in a year. So because it's daily, I want to take that average daily and multiply it by the number of days in a year. Well, the number of trading days in a year. So I'm multiplying it by 252, the number of trading days in a year. And now I've got the drift rate, the mu, of 0.629. So yeah, an annual return on investment would be a loss of like 63%. Let's go back to our formula here and see what we did. So I got the average daily returns and then multiplied that daily return to get their drift mu by the number of times per year. So our returns were daily. That was only 6 months of returns. It doesn't matter how many returns I have, it's the time span in between them. If the time span in between the prices is daily, I would multiply by 252. If it was weekly, multiply by 52. If it was monthly, scale it up by multiplying by 12. Because our drift, our mu, is we're expressing the yearly number. Now let's look at volatility. Volatility is going to use the standard deviation of the returns. Standard deviation, we're using the divided by n minus 1, and then we're going to multiply it not by the number of times per year, but the square root because of that big square root. So the square root, let's take a look at our spreadsheet again. I want the standard deviation, so equals, I want the divided by n minus 1, so I want the, from Excel, the S, the sample one. I want the standard deviation of returns. Here's the standard deviation of daily returns, a measure of how jumpy the stock is. But to get the volatility, I want to take that number and scale it up. So I'm going to multiply by the square root of, because it's daily, 252. There's a measure of the volatility. Volatility is always a positive number. So we've got our drift and our volatility. So this is the same stock, this Beyond Meat stock. And now I've got weekly returns. So there's 7 days in between each one of these data points. I've calculated the returns in the same way. If I would have bought it at 625 and then sold it at 560 over the week, I would have lost money. I would have lost 10%, 0.104. If I get the average of those returns, I'm getting minus 0.1, minus 0.01, but those are weekly returns. So I want to scale that up. I want to multiply it by, in this case, 52, because they're weekly returns. So the drift, if I use weekly data, would be minus 0.698. If I used daily data, I got 0.63. That's different. I'm using different numbers. These are estimates for the real return. Let's look at the standard deviation then. So I'm going to take the standard deviation of those returns, these weekly returns, and I'm going to need to make it volatility, I need to multiply that by the square root of 52 in this case because it's weekly. So using weekly data, I'm getting a smaller volatility. Using weekly data, it's less jumpy. Well, the number indicates it's less jumpy. Our techniques were correct. Apply the standard deviation of return times the square root of number of times per year. We're getting different numbers because we're using different data. So don't be surprised when different people give different answers for what's the drift and what's the volatility.